3. Free falling. Objects are attracted to fall to Earth's surface. They fall in a straight line with constant acceleration of g. In this case, the resistant force of air is disregarded. Therefore, either stones or feathers will fall at the same constant acceleration, which is g. 1. An object falling down. The falling of an object in a straight line has two patterns, which are the free fall and the throwing fall. If the object is free falling, the beginning velocity of the object will be 0, whereas if the object is thrown down, the beginning velocity of the object will be more than 0. However, the acceleration will be the same, which is g. In the calculation, the formulas of motion in a straight line are used, but the acceleration is fixed as g. Example 11. Drop an object straight down. Find the velocity of the object at the 12th second and the distance of the object which falls for 20 seconds. The velocity of the object at the 12th second is 120 meters per second. The distance which the object falls is 2,000 meters. Example 13. A man observes an object falling from the roof and hitting the ground with the velocity of 20 meters per second. How high is the roof from the ground? The roof is 20 meters above the ground. Example 14. Throw an object down with the beginning velocity of 5 meters per second. What is the distance of the object when it falls for 10 seconds? The object falls for 550 meters. Example 15. Throwing an object down with the beginning velocity of 4 meters per second. How long does it take for the object to fall down 768 meters? It takes 12 seconds for the object to fall down 768 meters. 2. Throwing the object straight up. Objects which are thrown straight up are attracted by the earth to fall. Therefore, the objects will move slower with acceleration, minus g, until the velocity of the object reaches 0. At that point, the object is at its highest peak. Afterwards, the object will start to fall down. Notes. 1. The acceleration is always g. It is deemed that the object moving straight up will have a positive direction but moves with retardation. However, when the object falls back down, it moves in the opposite direction. Therefore, this time, the direction is negative. 2. For the velocity from the calculation, if it is positive, it means that the object moves upwards. However, if the velocity is negative, then the object moves downwards. 3. The amount of distance is the amount of displacement. That is, if the object is higher than the throwing point, the displacement is positive. However, if the object is below the throwing point, the displacement is negative. The s that is calculated from the formula is the amount of displacement. 4. The formulas are exactly the same as the formulas of the object falling down. Example 16. Throw an object straight up with the initial velocity of 40 meters per second. Find the velocity at the 3rd second and the 6th second. The velocity at the 3rd second is 10 meters per second. The velocity at the 6th second is 20 meters per second. The object is moving downwards. Example 17. When throwing an object straight up with the initial velocity of 50 meters per second, if the object moves for 7 seconds, how high is the object from the throwing point? The object is higher than the throwing point by 105 meters. Example 18. A man stands at the cliff, which is high up from the ground. When he throws an object straight up with the initial velocity of 30 meters per second, the object falls to the ground below in 10 seconds. How high is the cliff from the ground? The cliff is 200 meters high up from the ground. Example 19. The student stands on a building's roof, which is 40 meters high up from the ground. The student throws an object straight up and observes that the object falls down to the ground 8 seconds. What is the initial velocity when the student threw the object? The student threw the object straight up with the initial velocity of 35 meters per second. Conclusion. 1. Relation of quantities concerning motion. 2. Formulas used in the calculation of motion in a straight line. 2.1. Moving with constant velocity. 2.2. Moving with constant acceleration. 3. Formulas used in the calculation of an object's falling down.